Today I'm going to show you how to do multiplication in floating point notation. Here are the steps. First, you want to get the sign bit with the XOR gate. Next, you want to denormalize the exponent part and then multiply their mantisas in 1.m form to get the working exponent. After that, we place a new exponent and that should be it. I'll show you the steps clearer in a little bit. So first, we get the sign bit. XOR. We have a 1 and a 0. 1 XOR 0 is going to be 1. So our sign bit is going to be 1. You can think of it this way. If you multiply anything with a negative number, it's always going to be negative, right? Same goes here in floating point. So 1 and a 0 make a 1. If it was 2 1s, then it would be a 0. If it was 2 zeros, then it would still be a 0. So let's do 1. Next, we want to denormalize the exponent and multiply the 1 point mantissa. So I'll show you the exponent part first. So this is 128 and then 2, so that's 130. So that's 130 minus 127. And this is 128 plus 1. So that's 129 minus 127. So this is going to be 3. And then this is going to be 2. Now that we have these values, we want to add them together. 3 plus 2 equals 5. 5 is the working exponent. So that means 127 plus 5 is 132. That should be our exponent part. So 132 is 128 plus 4. Just move that here. Next, we're going to be multiplying the mantisas, these. So that's going to be 1.0011 and 1.0001. We don't mind the exponents here. There's no 2 times whatever. We just multiply them straight up. So this is going to be a bit lengthy. So 1 times 1 is 1, and then another 1, then 0, 0, then 1. Then that's going to be 5 zeros. Then 5 zeros again. I guess I'll move this. I'm running out of space. And then another 5 zeros. Then we just copy this. 1, 1, 0, 0, then a 1. Bring these down. 1, 1, 0, 0. That's 2, so 0, 1. It's another 2, so 0, 1, 1, 0, 1. And then this is where we're going to be placing our decimal. After that, this is our new mantissa. And then, remember this. So that means this thing's exponent is 2 raised to 5, which is just that. So if you wanted to check, you'd have to shift to the right 5 times. I'll show you that later. But for now, this is going to be our final answer. So now we can get to checking. So let's take a look here. So this is going to be 132 minus 127. It's going to be 5. So we already know that. So now we have 5. We're going to use that to shift 5 places to the right. So 1.01000011, right? 4 zeros. Then we shift to the right 5 times. 1, 2, 3, 4, 5. So then that's going to be 101000.011. And then we can get to converting that. That's going to be 1, 2, 4, 8, 16, 32. These are zeros, so just ignore them. 32 plus 8 is 40. and then we can convert this part here. So 0.011. This is going to be 0.5, 0.25, and 0.125. So this is 0, ignore that. 0.125 plus 0.25, that's going to be 0.375. Combine these two together, we'll get 40.375. This is our sign bit, 1, so it's negative. That's our answer there. And then, if you want, we can double check our checking. So that's going to be negative 9.5 times 4.25. So 4.25 times negative 9.5. So that's 25 there. That's 12. That's 21. Then that's 45. And that's 22. And that's 38. Bring that down, add that. Add 4. Remember, that's negative, so add a negative symbol. And then we count the number of decimals here. So that's 1, 2, 3. 1, 2, 3. That's where we'll put our decimal point. And as you can see, they are the same answer. Very nice.